what is the basic definition? Electric field strength at a point is defined as force experienced per unit test charge kept at that point. We do have two things, one point charge, other is a test charge. So what is basically a test charge? So I think let me differentiate between what is a test charge, what is a test charge. It will not produce field of its own and will have very negligible amount of charge. Like this will define the test charge. It's ideal. It's like a idealization, nothing called like a practical. It's like a, ideally we are introducing the one called like a test charge. And what is the test charge? Test charge is a point charge. Again, it's a point charge only. What is the symbol for test charge? Q naught will write it. Okay, I am having a point charge. What is the charge of it? Let it be minus Q. Negatively charged. I kept it here. Let it be fixed here. Then it will produce field around it. So this is one imagination is what a student should develop. For any charged body, surrounding it, it will have some sort of like a sphere of influence, we'll call it. Later, the sphere of influence, we are going to call it as a field, electrostatic field. Then any other external charge, if it is present in this field, the field will exert a force on that one. So therefore, what is this force of interaction between the charges? It's a field force, not a contact force. In mechanics or the pen, we came across the contact force, whereas here what pen, it's a field force. the test charge, this test charge Q naught and this point charge, they're not in contact, but still what pen, they're exerting force on each other. How it is possible? Because the point charge minus Q, the negative point charge minus Q, it will produce field surrounding it. And any other external charge, if it is present in that field, the field will exert a force. Get instance? So a new type of force is what I am trying to introduce. What is that? It's called like a field force. So the Coulomb's force, the force of interaction between point charges, no, it's not a contact force. What it is, it's a field force. It's a totally different, the forces what we studied in mechanics, like tension, friction, normal contact, all what they are the field, they are the contact forces. This called like a field force. The idea of field is introduced, FIELD. So any external charge present in the field of this point charge, the field will exert a force, and because of that, the test charge will experience a force. Let me take two test charges. One I'll keep at a 0.1. The other test charge, let me keep at a 0.2. Let me keep it a 0.2. Then what we notice is like, which will be greater, R1, R2 less than R1. See it. And we know force of interaction is directly proportional to square of distance between point charges. Inversely proportional to square of distance charges. So therefore, F2 should be greater than F1. F2 should be greater than F1. Means this test charge will experience more force than this particular test charge. Then the test charge will have a mass. So if I release it, if I set free to move, because of this force, it will get accelerated. Because of acceleration, it will acquire a velocity, it will undergo displacement. It will undergo displacement. Then we know that let in a given interval of time, both let it undergo a displacement dr. Then what is the work done by the force? How you write the work done? Or we write work done? Work done equal to, let me take a smaller nib. Work done equal to W2 equal to F2 into R, W1 F1 into dr. Now from the idea here, which will be greater? F2 will be greater than F1. Then definitely W2 will be greater than W1. Means who is doing work? Means now I'm bringing the idea of the work done. How the work done? Because you say like, okay, the force, these test charges are free to move. They'll experience a force. Due to that force, what happens? It will accelerate. Okay, now due to acceleration, the test charge will acquire speed. Then it has acquired kinetic energy. From where this kinetic energy has come? Somebody should supply. So who is supplying this kinetic energy to the test charges? The field. What this field? The field does work. For the field to do work, it must possess energy. That energy is what we are going to express. That I'll call electric field strength. Got the idea? So now the field is possessing energy now. And the field as it is doing work. So if a force is capable of doing work, if an agent is capable of doing work, then it must possess energy. That energy is what we are going to express. We are trying to derive a formula to express that field energy. That's what I'll call electric field intensity or strength. How much the electric field there, or what is the strength of the field? That everything we are just calling as electric field strength. This is the basic idea. I'll put once again. The test charges are free to move. The test charges having a mass. The test charges will experience a force. You can see here F1 and F2. Because of this force, it will accelerate. Due to acceleration, speed will change, speed will increase. Due to increase in speed, kinetic energy will increase. From where this increase in kinetic energy for test charges? How kinetic energy is increasing? Yes, the field is what? Supplying energy. So the field must possess energy. The field is doing work. For the agent to do work, it must possess energy. So therefore, that energy of the field is what we are trying to express by a physical quantity called as electric field strength. And what is the definition? It says force experienced per unit. What is the field strength at a given point? I want field strength at this point. What I should do? The force experienced per unit test charge kept at that point. Now, what is the force of interaction? K, Q, Q naught by R square. Q naught get cancels. These two will cancel out. Then what will be left over? KQ by R square. Only these quantities will be left over. So this is the electric field. What is the electric field? KQ by R square. And how do it will be? As I move away from the point charge, the field strength will decrease. Then what is the direction? It's a vector quantity. What is the direction? The direction in which the unit test charge experiences a force, that should be the direction of E bar. Okay, no, there's a negative charge and test charge will be always positive. You know that test charge will be always a positive. Then in what direction it will experience force? Towards left. So what is the direction of electric field here? It should be towards left. If a positive point charge is kept here, if a positive point charge is here, I'll keep a test charge. Test charge should always positive. Test charge should not be negative. There's one very important assumption is what it was being made. The test charge should always be a positive point charge. This is a negative point charge. So let me write what do you mean by test charge. Very, very, very important. The test charge will be a positively charged particle. Test charge should not be negative. It's a convention. In the beginning of electrostatics, starting from the Coulomb solvent, the test charge, they assumed it to be positive. So we should follow that convention.